So here the first problem states that graph y is equal to the square root of x minus 1. And so again, more about graphing functions. And again, to familiarize yourself, so this is your x-axis, this is your y-axis. And so really we're plugging in points. So obviously if we place 1 here, right, we should see that we have a point here, right? This is 1, comma 0. Similarly, we will be plotting more points. Now, if you conceptualize this problem, really if x is, say 17, right, 17 minus 1 will give you 4. But as your x increases, right, your y will not increase as substantially because you need a larger number, a larger x value for the entire radical to give you for your entire radical to give you the next possible whole number value. And when I say what I mean by that is, like, for instance, you have 17 minus 1 is 16, so the root of 16 is obviously 4, right? And similarly you will have to go much more. For instance, you'll have to say that x is equal to 101, and only then does y equal 10, and so y has increased only up to 10, whereas x is all the way, it has gone up to 101. And so you see that you don't even have to plot points. So, sketch for this would just be like something like that, because your rate at which the function is increasing is not as fast. It's increasing but at a slower rate as x increases. So your graph looks something like this. Now, to determine the key features of the graph, again, it's always important to understand the x-intercept, the y-intercept. Again, the way how I remember it is x-intercept, we have the x, it's the value of x when y is 0. Y-intercept, the value of y when x is 0. So x-intercept being the value of x when y is 0 is obviously 1 comma 0. The y-intercept being the value of y when x is 0, well, if you think about this, clearly this is not crossing the y-axis, therefore your y-intercept is actually undefined. But if you think about this, really, when I say the y-intercept is the value of y when x is set to 0, we can do that. And so we see that y is equal to the root of -1, and the root of -1 is really I. Remember the imaginary value I that stands for the square root of -1. And so really you can, for the sake of it, you can say that your y-intercept is 0 comma I, but really it's just undefined because it's not crossing the y-axis. Then comes your domain, right? And for your domain here consists really the way how I would show the notation for the domain is, you want to make this bracket, right? And then you want to always say it has all the real numbers, and then you put this semicolon such that x is greater than or equal to 1. So that's your domain. And that makes sense, right? Because obviously it has to, if it's equal to 1, then your y is 0. If it's less than 1, that's a problem, because then you will have a square root of a negative number, which you know is not possible. So that's your domain. Then comes our range. And just looking at your range, you know that the lowest value you see here for y is 0. So again, we say that it's all real numbers such that y is greater than or equal to 0. So that is the first problem. Again, just graphing. So thanks for watching.